Hello everybody, this is Mac, and we are going to talk about using the distributive property to solve equations. Now before we get going, if you just stumbled across this, I have lots of math videos at maxtutorials.com. If you go there, you're going to see a whole sequence of math. After we do the distributive property, we're going to do two-step equations, and that's going to turn it into a one-step equation. And so if you're not quite familiar with that, all you have to do is go back to those videos and you'll see what we're talking about. Now, in the chapter 1 over on the maxtutorials.com, we talked about the distributive property. By the way, this is version A. I'll have 3 versions of these. I go a little slower in the first version. So when you see a number in front of a parentheses, you're going to multiply it by both. So this right here, we're going to get 3x plus 12 equals 24. Once we get to that stage, now it's just a two-step equation. I'm going to go pretty quick because I have previous videos that talk about that. We want letters on one side, numbers on the other. So I'm going to subtract 12 from both sides. And that's going to give me 3x equals 12. We're going to divide each side by 3. And that's going to give me x equals 4. So really, it's the same as the two-step equation. The only thing is we did some distributive property before we did that. Now, here's a part where people sometimes mix up on. I'm just going to go down the column, even though it's going the odds. That's okay. Now here I have to look at this as a -2 times both. So watch the way I say it and make sure you say it the same way. -2 times x is -2x. -2 times -5 is a positive 10. Okay, because remember, a negative times a negative, you're going to get a positive, okay? So now I want to get the letter by itself, so I need to move the number over. So I'm going to subtract 10 to both sides. They die, and I'm left with -2x. Notice how I keep bringing that negative down. Okay, if you're going to make a mistake, it's usually going to be that, okay? So that -2 keeps going. X equals -2 is my answer. Now we're going to go on to number 5. I'm going to multiply each of these by 4. And the new thing in this chapter is just that one step right there, distributive property. Now it's just a two-step equation. I'm going to subtract 4 to both sides, and that gives me my letters on one side, 4x, and my numbers on the other side. Divide each side by 4. Boom, x equals 4. All right, let's do number 7. I'm going to multiply -6 into both of these. -6 times x is a -6x. A -6 times a positive 2 is a -12. Be careful that you're following the sign, okay? So now what we're going to do here is we're going to make sure we get letters on one side, numbers on the other. So I'm just going to add the 12 to both sides. Boom, die. Now, make sure you bring down a -6x, okay? And that's going to equal, well, signs are different, so you subtract. Keep the sign of the bigger number, which is negative. Now, once I divide each side by a -6, boom, die. X equals a negative divided negative is a positive 3. Okay, let's go on to number 9. I have a 7 floating out here, so I'm going to multiply the 7 by both. I'm going to get 7x minus 7 equals 35. Letters on one side, numbers on the other. And I'm going to get 7x equals 42. Divide each side by 7. X equals 6. Slow these down if I'm going a little bit too fast. Now, if while they all kind of seem the same way, well, that's on purpose. I want you to practice the basic so that once we do like extension ones, you have the basics so down that the challenge stuff will actually be quite easy. All right, so I'm going to add 18 to both sides. That's going to get my numbers on one side, letters on the other. -3x equals, signs are different, so I subtract them, keep the sign of the bigger number, which is negative. Divide each side by my -3. Make sure to always keep that negative going. Negative divided by a negative is a positive. Okay? Number 13, I'm going to multiply 9 by everything inside the parenthesis. That's going to give me a 9x minus 27 equals 45. Now, it's a minus 27, so to move the 27 over, I have to add 27. Okay? They go away. 9x equals, let's see, that's a 2. Carry the 1, that's a 7. And if I divide each side by 9, if you know your 9's times tables, you're going to get x equals 8. Okay? Number 15, I'm going to -4 into both of these. -4 times x is -4x. -4 times -7. Don't say 7 with a minus or anything. Just say it's -7. What's a negative times a negative? It's a positive. 28. And that's going to equal 20. So now I'm going to subtract 28 from both sides. Boom, die. -4x equals. Now, add a line, change a sign. Signs are different, subtract, keep the sign of the bigger number. Divide by the negative 4. Boom, x equals a positive 2, because negative divided by negative is a positive. Number 17, I'm going to take that 5 and distribute it to both the x and the 2. That would give me a 5x plus 10 equals 35. Now, letters on one side, numbers on the other. I'm just going to subtract a 10 to both sides. And that's going to give me a 5x equals 25. Now, I just divide each side by 5, and I get x equals 5. Boom, 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 boom. Whoa, what happened? Sorry about that. Okay. Now, 19, we lead with a negative. Sometimes this can give people problems. So if I multiply each of these by a negative, I get negative 8x. What's negative 8 times negative 1? It is a positive 8, and that equals negative 48. I'm just dropping it down. So now I have to move my numbers to the number side. Boom, die. Negative 8x equals, well, let's see. Add a line, change the sign. Hey, the signs are the same. So I'm just going to add them up, and I'm going to keep the sign. Now, once I divide each side by negative 8, I just need to know my multiplication tables. It's one of the trickier ones, but a negative divided by a negative is a positive, and 7 times 8 is 56. Ah, me and technology, okay? Never give an old person an iPad. All right, now look at how these all kind of look similar, okay? Oh, I should have put a box around that one. Okay, but they all have a very similar feel to it. That's what yours should look like. Have a process. If you follow a process, you're always going to end up winning. Okay. Not sure what happened there. Okay. Is that right? Yeah, it is. Okay, we're going to go on to number 2 now. So I'm going to take my 2 and I'm going to multiply it by each. Boom and boom. 2 times x is 2x. 2 times positive 3 is positive 6. Plus 4 equals 18. Ooh, wow, they put an extra step in here. So now on this one, before I do this, I have to see if I have any like terms. And I do. I have 2 numbers on the same side. Don't go minus 4, minus 4. Don't start doing that. You only do that when you cross. We're not crossing the equal sign. So here we're just going to go 2x plus 10 equals 18. Now you do the two-step equation, okay? We're going to get 2x equals 18, divide each side by 2, and you're going to get x equals 9. All righty, let's look at this next one. 3 times x, 3 times negative 2. That's 3x minus 6. Now, I have a minus 5 floating out here. That's fine. Just write minus 5. Whatever you don't do math with, you just copy it down. Now, look at this. I have numbers on the same side, so I got to deal with them. 3x, I'm just going to write it down. Now, I'm going to look at it like this. Negative 6, add a line, change a sign, plus negative 5. Signs are the same. I add, and I keep the sign. Equals 10. Now I'm just going to get letters on one side, numbers on the other, and I'm going to get 3x equals 21. I'm going to divide each side by 3. X equals 7. Boom. Okay, let's go on to number 6. Distribute the 5, and I'll get a 5x minus 20 plus 3 equals 18. And before I can start moving things around, I say, do I have like terms? And I do. 5x, signs are different, so you subtract, keep the sign of the bigger number, equals 18. Now, I just want to move that 17 over by doing the opposite. And this is basic two-step equations. Again, if you go back to my maxtutorials.com, you'll see that I have some videos on this, except for I don't know why I added 18. Okay, go away. It's add 17. I just got to be careful when I keep talking. 35, and then I divide each side by 5. Boom, die, x equals 7. All right, let's go on to number 8. I'm going to distribute the 6 across, and I get 6x plus 12 minus 8 equals 22. All I did was distribute and then copy. I have like terms. 6x, add a line, change a sign. Signs are different, subtract, keep the sign of the bigger number, which is positive, and that's going to equal 22. So now, letters on one side, numbers on the other. I want to get rid of that 4. Boom, die. And I get 6x equals 18. Divide each side by 6, and I get x equals 3. It's an ugly looking 6. A little better. There we go. All right, number 10. Let's go ahead and distribute this across. 7 times x is 7x. What is 7 times negative 1? Negative 7 is what that is. Now I'm just going to copy everything else. Plus 2 equals 30. Now I have some like terms here. So I'm going to have 7x, signs are different, subtract, keep the sign of the bigger number, and that's going to equal 30. Now I want to move the 5 over so I have all my numbers on the right. So I'm going to add 5 to both sides. Boom, die. 7x equals 35. Now I just divide by the 7. Okay, and I get x equals 5. Boom, 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 boom. Okay, number 12. 8 times both. 8x plus 40 minus 4 equals 60. I did the distributive part. Now I have to collect like terms, which is right here. 8x plus 36 equals 60. Now I'm going to subtract the 36 because I want that to equal 0 on the left. And I'm going to move it to the right. 8x equals, what is 60 minus 36? The answer is 24. I could do this pretty quickly in my head because I watch a lot of basketball. I remember growing up, Lakers were really good. That was the Magic Johnson days, right? And they were like winning every game by like, 18, 22, 27. And so, doing stuff like 60 minus 36, Lakers 60, anybody else 36, and you could start to add up and find out how much they were winning by. It's funny how much you kind of learn stuff if you put it to a real life context. Okay, to me, adding in my head, watching Laker games. Okay, here we go. So now I have a letter here and I've got numbers here. 9x, signs are different, so we're going to subtract them. Keep the sign of the bigger number, which is negative, and that's going to equal 34. All right, letters on one side, numbers on the other. So let's add 20 to both sides. Boom, die. 9x equals, that's going to be a 54. And if you know your multiplication tables, you know that 54 divided by 9 equals 6. Whenever you have two digits and they add up to 9, 5 plus 4 is 9, you know that it's going to be divisible by 9. 63, 6 plus 3 is 9. 72, 7 plus 2 is 9. 81, 8 plus 1 is 9. So if you haven't learned that trick, that's a way to figure out your 9's multiplication tables. 3x minus 21 minus 6 equals 9. Like terms, 3x, I'm going to add a line, change the sign. That's going to become, signs are the same, add them, keep the sign, equals 9. Now I'm going to add 27 to both sides. Boom, die. And I get 3x equals, well, what's 27 plus 9? That would be 36. Divide each side by 3. X equals, 3 goes in the 3 once, 3 goes in the 6 twice. Okay? 18. Two more and we'll be done with this one. Good job working through. 4x plus 16 plus 8 equals 40. Now I want to collect my like terms. So I'm going to get my 4x plus 24 equals 40. Letters on one side, numbers on the other. So I'm going to subtract my 24. And I'm going to get 4x equals, that's going to be Lakers up by 16. Now I'm going to divide each side by 4. X equals 4. Okay? Doesn't work as well with the Lakers as it used to. Lakers aren't as dominant as they used to be. Here we go. 5x minus 10 plus 15 equals 40. Not that I'm bitter about it. The league basically made an anti-Laker rule. They all got together and said the Lakers aren't going to dominate us anymore. And they did a collective bargaining agreement that basically said, sorry, Lakers. Anyways, here we go. I digress. Signs are different, so we're going to subtract. Keep the sign of the bigger number, which is positive. And then they nixed the Chris Paul trade. Not that I'm bitter about that at all. They would have won the next 5 championships with that. Oh, I'm sorry. We're doing math. Okay. Boom, and then boom, and then boom, and then boom, and then boom. Die. X equals 7. Okay, there we go. Now, if you look at it, they all look like they have a process as far as the steps. And if you listen to me, I would always say this times this, add a line, change the sign, take the letters on one side, numbers on the other. I keep saying that in my head all the time. And when you get a process like that, that's when you start to become really successful in math all the time. All right, there's version A. If you feel great about it, wonderful. If you need more practice, please go on to version B, and I'll see you guys there. Take care.